My favorite person. I don't use Siri, so that's the only voice.
Hello, everyone. Welcome to day 2, Moving the Cities. Today, we're going to be starting our panel discussion. That's basically going to be a primer on SDG 9 and a discussion with some of our resident experts in the subject matter. So I'll start introducing myself. I'm Brandon Barber. I'm the Design, Innovation, and Outreach Coordinator in the School of Engineering, and also an instructor. And a lot of what I do is within the Innovation and Entrepreneurship program, which is directed by Dr. Buddy Clark. So I'll let you all introduce yourselves. Buddy, why don't you go?
Sure. So yeah, I am Buddy Clark. I'm a professor in mechanical engineering and material science. I've got the most gray hair here, so but obviously I've been around here the longest. I've done research mostly actually in dynamic systems controls and mechatronics, sensor development. But I've partnered or joined up with the Sustainability Center here, the Mascaro Center for Sustainable Innovation, a number of years ago, done some energy harvesting type work. And other work that might be considered more sustainable research.
Well, I've got the most hair, so what does that mean?
Then you go next.
I go next. I'm Kent Harries. I'm a professor of structural engineering, or civil and environmental engineering, I suppose, but I'm a diehard structural engineer. I also have an appointment with the School of Architecture here, or the Department of Architecture. With respect to kind of the topics at hand, I am a bit of an expert in infrastructure repair and infrastructure renewal, renovation, and particularly in using innovative materials. So most of my world is steel and concrete and wood, but I do a lot of work with things like carbon fiber and all sorts of other. We've done some work with mycelium even, and I suppose around here I'm known for my bamboo work, which I know gets me laughed at, but bamboo is fun. And also, I think in relation to this, kind of the topic here, do a hell of a lot of work with codes and standards development. And ultimately, when we start talking about policy and we start talking about actually getting things done in the civil infrastructure world, that's where it starts.
Okay. Dr. Sanchez.
Fantastic. Hi, lovely to meet all of you. My name is Dave Sanchez. I'm an associate professor in civil and environmental engineering. I'm actually on the other side of Dr. Harries, where I'm an environmental engineer. And a lot of my research would focus on water. Right? These are tracking and treating emerging contaminants of concern, but there are broader interests around water, energy, and food. In my other hat, I'm actually the associate director for the Mascaro Center for Sustainable Innovation. And that's a university center that's kind of leading the thrust for sustainable research and sustainable education here at the University of Pittsburgh, making that available to lots of different students. So very familiar with the UN SDGs, familiar with how they overlap, and excited to talk to you about it.
All right, thanks, everyone. This is going to be a pretty free-form conversation today, but we are going to give you all the chance to ask some questions towards the end of this session. And I've also got some questions that some of you have submitted. But we'll just start off by just really briefly talking about the history of the SDGs. They came about and were accepted in 2015 with a lot of really ambitious goals for 2030. And we're going to be focusing on SDG 9, which is innovation, industry, and infrastructure. So this is all about building resilient infrastructure, promoting inclusive and sustainable industrialization, as well as fostering innovation. So there's a lot of broad topics under that. I think we can speak to many of them. So why don't we start off with, let's see. We could start off with target 9.1. So that's developing reliable, sustainable, and resilient infrastructure. That is really important for, I think, a lot of our home countries right now. And so what are some of the challenges around, like, why aren't we investing in infrastructure and why is it failing? And then what are some of the opportunities that arise around that?
Before you get a full 40-minute response.
Yeah, maybe I'll leave and.
Yeah, I mean, I think it's important, like, when you look at symbol SDG number 9, it is ambitious, it is bold, but it is also critical. I mean, that's what you get when you're trying to get all the world's problems into 17 goals. I think it's important to understand that these overlap with a lot of other goals. So there's 17 goals, there's 169 targets, and then 260 some indicators. And so, like, that's a lot that's going in there. And so all of these, I mean, when you look at the different targets and indicators, at least for SDG number 9, you know, they're very, very broad. So to your question, I was like, obviously, as an engineer, my answer is always it depends. And you know, maybe as a person, you know, working in it, like, it's pretty complex. I think we are. I just don't think we are not doing it to the scale that we need to. And you know, there's lots of room for students like you to, you know, work on projects or even bring to light some of the issues that we're facing.
Yeah, I think some of the issue, I think, before we get started on this is talk about, you know, what is infrastructure? And one of the very best definitions that I've seen of infrastructure, and I'm talking about civil infrastructure now, is it's the bits of society that are too big for individuals or individual companies to deal with, right? We're talking about the stuff that has to be built in, you know, to paraphrase Obama, by us. We built this. And that leads to one of the issues. I think it's really, I've forgotten when SDGs had come out. I didn't realize it was so recent, but it was pre-COVID, so it could have been decades ago, right?
Yes. Yeah.
But how can you set goals? And I'm playing devil's advocate here intentionally, talking about something that has a design life of 75 and 100 and 125 years, and say, well, what's going to happen 15 years from now? One of the best questions I was asked this years ago was envision what do bridges look like in 2060? It's unlikely I'm going to make it to 2060, but what were they going to look like? They're going to look exactly the same as they do today, because almost every bridge that exists in 2060 is standing right now. If we think about downtown Pittsburgh, or most cities' urban environments, apart from places where we may be moving to. And so that's one of the problems. We're trying to impose, we have to deal with what's here. One of the we talk a lot about sustainability in classes and which materials are better, and you know, how can we shave a couple percentage off of the carbon emissions of cement or something like this. But if I have an urban environment like we're sitting in, what's the most sustainable solution? If we talk about construction, let's talk about the housing crisis that we're having, is reusing existing buildings, because the combination of demo and rebuilding is never going to beat the excessive work I may have to do to bring the building up to speed. And we saw that in Benedum over the last, 12 years, as they took a building that was clearly not fit for purpose and turned it into a newer building that, okay, I'm being recorded, aren't I? That's always going to be the more sustainable answer. And it's funny because I don't think we teach that too often. We don't say, well, what do we do with what's out here? I'm looking at a bunch of buildings now that are being reused. I mean, they certainly are rebuilding the Presby, but they're also have done remarkable work inside the old building, which is now what, about 75 years old, I think.
For sure.
So the time frame is different, I think, when you talk about it's funny to see industry and infrastructure put into the same pot if you're thinking about temporal relationships.
Yeah,
because
I think it's just because of scale.
there's an
Because
order
like
of
you said-
magnitude different.
Yeah, but like you said, it's something that, you know, is built by us, or it's like, you know, just as these are larger critical lifelines that need to be constructed, right?
It also doesn't travel with us.
Yeah.
So if I up and move, I take my car with me, I take my furniture with me, but I don't take my house with me. But more importantly, I don't take the sewer that's connected to my house and the water pipes that are connected to my house and the roadway that's servicing my house. And if I move to a new build, somebody has to put in those pipes, those roadways, all of those services that I'm going to need, electricity and what have you. But we still have to maintain both. Maintain it at my old house, maintain it at my, or we say, fine, we're gonna give it up and
So one of the things that you mentioned was, industry and infrastructure, two huge things. But you also talked about, sustainability in terms of, efficiency, right? So, I think the industry part of this is interesting to think about, like, how do you incentivize industry to be sustainable? Like, can sustainability be the more commercially viable way forward? And what are some ways that people may have done that or work towards that?
Well, I mean, I think the proposition, like, the question is really, it creates an opportunity for innovation. Because sustainability on this triple bottom line of, it's, there's a social aspect, obviously there are environmental consequences, and we also have to consider the economy. I think for us, I was like, because we're coming to a head of, hey, here's what we've done before, here are these other things that are coming of age, here are the old industries, but we still need to provide these human services. Sustainability, I do think, is an opportunity because you can actually rethink and recreate how you serve the population. For example, the retrofitting of houses. I was like, retrofitting of houses, the retrofitting of buildings. I was like, that's not something that has been considered at the scale before. And so if you think about the impact alone from the scale is going to be significant. I think if you do it in a sustainable manner, using creative ways, I think you have a chance to really affect each of the triple bottom line. And that's going to be something that industry will latch onto it because it's valuable to communities, to countries and things like that.
but we have, and I think you said it, I mean, we're sitting here in an academic environment and we have this bad habit of being somewhat altruistic, thinking that these are things that need to be fixed. And we certainly, I think we all agree. But when it comes to, how do you incentivize that? We sort of have the stick out there, right? Global climate change is a great example. The stick is coming, 2 hurricanes back to back. But where's the incentive to make changes? And unfortunately, do we not need to kind of move away from this sort of, I don't want to be called a communist here, but move away from this market. The dollar is still driving a lot of these. If I want to come up with a way, we're doing a project right now with the architects of finding a potentially mass office to residential conversion. We're looking actually at the BNY Mellon Tower in downtown. That will never happen because there's no money in it. We know that. It's an artificial project.
Sure.
How do we incentivize it? That's the thing.
So who do you
We have
incentivize
that.
it? So
That's a good question.
there's
I wish I
always
knew.
different stakeholders in any of these problems. And I think to Brandon's earlier point or question, how can industry be more sustainable? Well, you can incentivize customers to buy into what you're selling because you've made it sustainable. I think that's one route. The triple bottom line you're talking about at some point has to convince the investors or the board of directors that it's profitable to do that. But I don't know that you have to do all of those things. If you can, that's a
Yeah, you're
That's-
trying to balance, right? I mean, you're
Yeah.
trying to balance across those three, but it's always in progress, right? It's not like, hey, this is purely sustainable. It's like, no, it's often comparative. This is more sustainable than a previous one, and so that's why it replaces.
And so it's really maybe about learning which of those stakeholders do you really need to convince in order to make it happen at all.
Yeah, because consumers do move on to new innovations, right? I mean, like, as new things come, like, consumers make their voice heard with, how they purchase. But the other part to your answer, Ken, I was like, I think some of the work you do with Bamboo, right? Because it's unique and can shift the paradigm in terms of how we provide that service, let's say shelter. I was like, I think those are unique things to consider that could potentially replace how we currently do it. And right, when you can do that in the value proposition, hey, this is actually more environmentally friendly, maybe it's at the same cost, but provides the same service to the same quality and safety. I was like, I think those types of innovations are the ones that can really push the base.
And that is the approach that we're taking, keeping in mind that we're talking about that capital I infrastructure, which is too big for individual, we're talking about something that is more of a societal move.
Yeah.
And so maybe it's easier to see the incentivization there, but we still have Bamboo is a great example. The approach that we've taken, and thus far it's been successful, is what's the problem? It's not that we don't know how to build with bamboo. We've been doing it for thousands of years, much longer than any other material that we typically work with apart from stone maybe today. But there was no codes, there were no standards.
Yeah.
And as an engineer, that's what I need to put I gotta hang my hat on,
Yeah.
on something. And it's interesting because the driving force in the early work that I did with Bhavna, like, so going back when we first visited India, right?
Yeah.
Was being driven by a combination of the insurance and the banking industries. I don't understand exactly all the intricacies, but the Indian banks wanted access to the North American or the United States market. And part of the trade was going to be that insurance companies had access to the Indian market, which was largely an uninsured market. And so it was the insurance industry that was driving this, because if I'm going to insure your property as an insurer or reinsurer, I need something that I can hang my hat on and say it's an insurable thing. Interestingly, manufactured items, cars, as an example, or smaller, toasters and whatnot, that you could argue that it's there because there's a point where you can kind of inspect and do. When you're talking about housing and you're talking about building structure, you're talking about something a little bit different, where the only assurance we have are these codes and standards, and whether they're being upheld or not in the inspection process and what have you. So that was how we're trying to incentivize it, but I will still tell you that if Brad Pitt builds a house out of bamboo, that's going to be our best selling thing. Yeah, right.
Sure.
So, another large piece of this whole SDG and of this whole kind of class and event here is innovation. And so, innovation is creating new methods, creating new things, ways of doing things. So how can innovation support all of these huge, ambitious goals and problems?
So let me jump in to start with, Brandon. I forgot in my introduction that I'm the director of the Innovation Entrepreneurship Program here, although Brandon had just said it before that. That doesn't make me the spokesperson necessarily for that, but some of the things that have been mentioned already have been popping up thoughts in my head that innovation is not just about the technology, the low CO2 concrete method, right? Or any kind of new structural method. That's maybe a necessary part of a lot of this, because we're engineers, we're talking about making things. But one of the things that we try to focus on is, if it's just technology, it's probably not going anywhere. So you need to think about all of the stakeholders involved, all of the things that have to be done, people to buy into it, who's going to try to shoot it down. All of those things are important in getting anything to actually be put into practice. And you keep talking about incentivizing people and obstacles, and even the codes and standards, right? If we as engineers don't think about all that stuff, it's really unlikely that our ideas are ever going to get anywhere. So I don't know if I have an answer other than to elevate that and say it's really important to think beyond the engineering classroom.
Yeah, no, I mean, it's systems thinking. If you think, anybody who thinks it's just technology or technique, and I've got some novel, widget here, and I was like, that falls short, especially when it comes face to face with who it interfaces with, policy, things like that. So I think it's important to think innovation is just not something novel, some turn, like some new, new. Yeah, it can. Yeah, it definitely can be. I mean, sometimes you can have innovation by subtraction too, right?
Yes,
but it's really ultimately it's by adding value, right? And I was like, well, how is your whatever you come up with, students? It's like, how is that serving, creating value or making their lives better, right? I mean, sometimes people talk about costs. Engineers talk a lot about that. But maybe it's providing another social service, or maybe it's better for the environment. Thinking about all of these, and then thinking about why would anybody outside of our group who created it care?
Well, and I think you're kind of skirting around another issue that I bring into a lot of my discussions is it's always it's got to be appropriate engineering. And what works for us, and I'm looking around at the cool stuff in Brandon's office, does not work for most of the population on this planet.
Yes.
And example is, so you guys know testing equipment and whatnot, and so I do a lot of work on test methods. But pretty much from day one, if a test method involves tension, I'm going to throw it out, because most labs in the global south just can't do tension efficiently. But compression is easy
Yeah.
because you can always get gravity to work for you, and everybody's got a press or a thing. So also that right in, the stuff that Ian Nettleship
Yeah.
is also working with. That's a piece that we often forget, is that, we're a small market, right? I mean, what the United States, even the entire United States is what percentage of the globe's population now? It's better, small.
Yeah.
So that's a good segue. So the SDG target 9.5 is enhance scientific research to upgrade the technological capabilities of industrial sectors in all countries. So you're all active researchers. What are some of the ways that you might see like this happening, like spreading this out?
I think a very good point is, first you gotta recognize your context. Sustainability is driven by context, and I was like, if you think, yeah, what we create here is gonna be translated to another country, just like you said, you don't take your infrastructure with you. So the first thing is to start with your context of like, who are you designing for and what space, and how do you actually be sensitive to that? I think the other part is, I mean, this is probably one of the motivating factors for trying to incorporate more of this low resource engineering or this frugal innovation around how do I create more value while stripping out the cost. And I think you just highlight a very nuanced and important example around, hey, if a test involves tension, right, like we can't use it. Same thing for Ian and his clay pot water filter, right? It's like, well, it has to be less than $2 to make. It has to be so that you can actually use local materials. I mean, for us, like one of the things we're doing in the lab is trying to find a better way to remove arsenic over from Pakistan. And so if we can create a new material, that's great. But can they create it on site using existing methods? And so that's an important piece about how we think about this. So it makes you change. You can't automatically assume that they have your lab, they have your technology, or they even care to do it your same way. I think the ideal would be, well, maybe they can leapfrog the way we do it, and they can actually create something that we aspire to actually incorporate.
So yeah, that's all great. This is exactly some of the challenges that the students are going to be facing. I guess right now, but mostly next week when they all get here. And you all teach some really interesting classes that like revolve around these topics. You mentioned innovating for public good, the NOCMAT class, non-traditional materials. And Dr. Cluck, your innovating for public good was one that came to mind. So what are some of the like methodologies that you might want the students to know? Like you've talked about like thinking about things holistically, but what does that mean? How do they do that?
So maybe not a process, but clearly something that's emphasized at the very beginning. I was like, your solution is only as good as how much you understand the problem. And the moment that you start like thinking, oh, I've got this, and you start ruminating in your head before you've actually talked to people outside of your building or in the context, I was like, that's a recipe for disaster. So one of the very first things is, validating what you think the problem is, learning that and validating it, not from your own words or your own thoughts, but validating that from actually working with stakeholders and people outside of your realm of influence. And so anything in the Sustainability Capstone, for example, they're required to do interviews, and it cannot be from anybody at Pitt's campus. Right? You have to go outside. You have to talk to others. And sometimes these are global projects where we have other partners and they connect them to other people. But one of the first things is how to interview and sit down and listen. Like I have to constantly coach them. I was like, you have to quiet your cleverness. All right. I was like, I know you're engineers, you're really smart, you have all sorts of ideas. Put that aside and ensure that you actually have something that's meaningful to them. And so that's the first part.
And that's hard to
Go ahead.
do though, isn't it? I mean, because it's easy to do if you're talking about a regional thing or something like that. But
Because we all think solutions.
I'm sorry,
We all think of solutions.
Like rapidly, right? You're like,
That's how we
yeah.
think, right?
but to engage stakeholders and to think about this in a global context, we are not well set up for that, despite what we're doing right now.
Yeah.
We do a relatively poor job. I mean, we did a great one a number of years ago, but it was by pure chance. It was an architecture program. I don't remember if you were around for this or when Nepal, my buddy from Nepal, was an engineer and was dealing with the earthquakes in Nepal and earthquake. And he agreed to actually mentor an architecture team. And then we surprised them when he showed up here in Pittsburgh for their final charrettes and things like that. But that unfortunately is still the exception rather than the rule, and that probably that falls to folks like us
Yeah.
to try and remedy. This is one example, I suppose, of trying to
Probably
do
why
that.
we're excited about it, but yeah, I know, normally it's the faculty who are creating these bonds and connections, or staff connecting and creating the long-term partnerships. Right, but we don't necessarily have the automatic infrastructure to do that.
And
So
and
to
it's
build on,
costly.
sorry, to build on, you were talking, techniques,
Sure.
things that we can share from our classes and whatnot. You already touched on getting out of the building, which
Yeah.
is one of the big ones for us. But
In this case, out of the country, right?
yeah, that's far out of the building.
Yeah.
But another one that I know we struggle with, and students often struggle with, is first of all, embrace the fact that everything we do is a guess or an assumption, that we're hoping it's right, but we don't know until we validated it. And the way we validate it is we form a hypothesis and we test it.
Yeah.
Right? So my suggestion would be learn how to form a good hypothesis that's testable, and the problem is we have to have thick skin that it's probably going to be wrong. And the tendency is to craft a hypothesis that can't be wrong.
Yeah.
Because we hedge our bets, right?
Mm.
But then we don't learn anything. So be willing to put yourself out there and say, I
Embrace
want to know
failure.
what the real problem is, or why this is wrong, because I've learned from that.
Yeah, no, I think it's part, I think the part that we don't maybe talk about is like, it's emotionally and cognitively hard to embrace that. Because all
Sure.
along in our school, it's like, oh, here's the answer. And so I don't like the questions like, hey, is this what you want? I was like, don't ask me, like, what does your data tell you? What does your
Exactly.
stakeholder tell you?
The whole system is set up against, embracing failure is critical.
Yeah,
right?
yeah,
Because we learn much more from failure. And in my world, where we talk about, let's go to the seismic world or something like this, we can't do tests. We have to rely on buildings to fall
sure,
down in
yeah.
earthquakes to learn something. But everything is stacked against us. How many journals in our fields are sort of vaguely similar?
Sure.
But how many journals really embrace data that is a failure?
Yeah,
There are
don't.
specialty journals out there that's like for like
That's right.
tests that didn't work.
Yeah.
But sadly, those are equally important. One, so that I don't go repeat your
Same
failure,
mistake,
you
yeah.
don't go repeat mine. Or in the case, I'll use my own dissertation as an example. There's a chapter in it that we basically concluded this will not work. There's good structural reasons. We tried it, it won't work.
Yeah.
About 20 years later, some really smart people from South Korea citing our work, saying, no, actually, we can make this work. And they did it.
Hmm.
So
Wow.
it also maybe identifies gaps, but we also don't have a way to reward failure in a sense. And right, I mean, I would hope that if we're doing our job right, most hypotheses are wrong.
Yeah.
Maybe that's not a good
I mean, I
thing to
think that's a
say.
lesson though for the students to kind of embrace that process, to test it.
That's
You know?
the point.
It's like, hey, this is gonna feel very different than your math class. It's gonna feel very different than a statics quiz, right? It's gonna feel different because you have an idea that you're generating and validating by constantly testing. And so the way you get ahead is like, how do I get it? And actually, as Dr. Clark said, how do I test this? How do I have an idea that I can actually test quickly, fail fast, and learn. And then you iterate, throughout that. But it feels very different, right? And so you have to embrace that when you're trying this out.
Well, you have to focus on the process and assessing on the process and not the results of
Yeah.
whatever.
That's
these
right.
tests are.
Absolutely.
I'm gonna go to some of the questions that
Sure.
the students have submitted. So I'll start with this question here from Unicinos, which is the university in South Brazil. So they this year experienced some really catastrophic flooding in May and are still recovering from that. There was a lot of issues with infrastructure, et cetera. So this question is, considering the increasing frequency of extreme events, developing a sustainable and resilient infrastructure is an urgent risk. How can countries that are more prepared and experienced in responding to climate emergencies help less developed countries adapt more quickly?
So which are the countries that are ready for it?
Yeah.
I didn't know there were any that were developed and ready to go.
I mean, for me, I think,
Iceland, no, they're having volcanoes.
I think there are different collaborative task forces that are looking to, engage, various problems. So for example, down where they have flooding in the south, I know that there's a National Academy effort to connect them with some of the small island developing nations. Right, because of, the king tides that they experiences in some of those floods. So I think, the collectively trying to solve that problem, right? It's like, hey, you know what, not all contexts are the same, but some contexts do actually rhyme or resonate with different people. Right, so it's like if you're in the south or you're on the coast, someone's like, well, what solutions do they have? Like, how might they be actually translatable to other places? So I think one of the initial things are some of those task force that are coming out, to address these. But I do agree with Ken. I was like, I don't know that any one particular place is specifically ready. I think it comes in different pockets. And trying to find those, can be difficult.
But recognizing it's a global issue, and it is harder and harder and harder these days, politically, any other way, to address global issues, right? I mean, we've got lots of global issues that are making other ones impossible to address.
Yeah.
But again, it comes back to incentivizing. And, I appreciate this isn't the audience for the, but we are all evaluated on certain metrics. And by going out and doing a whole bunch of work in the global south and whatnot, we're not likely, I mean,
Yeah.
we're fine. We got tenure. I don't care. But it's not valued.
Just pivot off of this if I was a student in this, in this challenge, I think one of the ways I do it, I'm from the island of Guam. So if I'm sitting in Guam trying to solve this problem, I think one of the first things I do was I'd look to see solutions in other countries, right? And then try to connect to those people who are doing. This happens often in research, right? You find some other ideas or some other cool initiatives that people are doing and look for it. Like, what do they say? You spend a day in the library will spare you a year in the lab. And the idea is like you can learn, from other people's mistakes, you can learn from other people's successes. And I think if you do that internationally with other people who share your context for that specific problem, that's probably the best way to go about it.
I would just add to that. I think that's along the lines of what I was thinking, but I think we grow up thinking it's not going to happen here. It's not going to happen to me. And the problem is we're seeing those events are becoming more severe, right? That's the whole part of the challenge. And so extending on what you just said, look to the places that did get hit by these events, the 1,000-year floods and whatnot, that weren't anticipated, and then look at the places that haven't yet, where they haven't yet occurred, and say, what should we be doing to prepare for that? So be a little bit more proactive.
But it's funny, before we were talking about this very issue before you guys got here, and this was years ago. There's also it's not going to happen to me. It's not going to happen in my backyard. I mean, I remember years ago sitting in a code meeting in the United States South saying, well, we're not going to adopt the hurricane requirements because we haven't had a hurricane here in 10 years.
Mm-hmm.
Okay. So there's also the sort of blissful ignorance. And I mean, part of it comes, I think, because we're seeing increasing damage. I mean, what would you do if we did have an event like Helene here, and we don't think about that?
Right.
And so a lot of it is that sort of, well, let's hope that there's not only do we don't think it's going to happen, we also just kind of hope it's not going to happen. Go on.
Okay, so I have another question here. This one's a little bit changing topics, but for those coming from backgrounds not specifically relating to sustainability, such as engineering or business, like many of our students are going to be from, can you tell the story of how you may have found a passion for roles revolving around sustainability or sustainable innovation?
So repeat that last part.
How have you personally found passion for sustainability and sustainable innovation in your role?
I think for me, I mean, I didn't, before grad school, really, I wasn't really working in sustainability. I think for me, I was always interested in how the world worked and, what the problems were and how it could work better, right? And I think for me, what forced me trying different things and failing at them forced me to say, hey, the solution has to be more comprehensive. It has to actually incorporate a bunch of other systems. It has to incorporate not only the environmental, but the economic and the social aspect and these stakeholders. And I found that sustainability invited you to think through things comprehensively. I think it gave you a chance to kind of consider all these different angles from which it can fail. And for me, it still comes down to the fundamental root of like, well, how do we solve problems to serve people? And I just think it does in a kind of holistic way, in a way where you can consider all sorts of angles, and a recognition that you need more than technically savvy people. You need people who are entrepreneurs, who are business people, who are, who know policy, who are collaborative, and that's how you solve it, right? Like, I like sustainability because it acknowledges readily upfront that changing the world involves group projects, right? And like, you have to work with a bunch of others, and that's just continued to resonate every year, regardless of the initiative I have in research or education.
It's an interesting question, the way worded, like how did we come to sustainability? And I now, because it's taken a long time to figure out what is sustainability, like, but what I realized is, I've been a structural engineer for 35 years. I had been practicing sustainability for 35 years because ultimately, yeah, 35 years ago, the only measure I was concerned with was pounds of steel, because pounds of steel is money.
Yeah.
But pounds of steel is also CO2 emissions. Pounds of steel is also transportation. It's all of these things. And to simply, and so I try to bring that into class. I mean, we talk about having to bring sustainability into class, and I argue, I as you guys know, I only teach design classes essentially. It's all about sustainability ultimately, and if really all you're trying to do is you're looking at lower the cost, which is usually what the client wants to see. Just define a different metric, or even the same metric. Often lower cost is good work. But I think the question was, how did we come to it ourselves? And I mean, I think that's a bigger picture. And I think that also kind of the way one was raised. I come to a lot of this as seeing as a professional responsibility. I mean, I'm a professional engineer. I have a license, and I've been treated very well in my, part of it is just giving something back, right?
Yeah.
Making sure that you're yeah, giving something back. So I think that was how I interpreted that question. Sorry, maybe I'm wrong.
Yeah, I mean, I actually have an answer for this for myself. So I fairly recently started working with plastics recycling nonprofit startup that was developing like localized collections and then cleaning and sorting and processing. And now we've been working on a variety of methods for, creating products from that waste. And, and it has a limited scalability, right? It's never going to turn into a giant corporation, but what it does do is create an opportunity for people to learn, to volunteer and do some of this work and see the reality of like the plastic situation, just how much waste there is. It's incredible. And then we can make some things that will bring some visibility to the issue. And I'm doing it because, I care about the city. I like doing the cleanups and having clean neighborhoods. I'm also a designer and I love interesting challenges. And there's some good constraints around like molding ground up number 5 plastics, So I think that's what it is for me, is just seeing like the challenge. And that's kind of what this class, like it's easy to make like event like this real like doom and gloom, but there are opportunities for making things better when you recognize all of these issues and challenges. So that I think I'm going to bring that up as like the final question. Like, for instance, in our friends in Brazil that have had all this flood damage, there's going to have to be a process of rebuilding. What are some of the opportunities in like improving the infrastructure and doing this in a sustainable way so that this doesn't happen again? Like, the incentive is we don't want this really bad thing to happen again, right? So what kind of stuff could you see coming from that?
I mean, I think the first thing that's coming to my mind is actually when I went with Dr. Harry's, we came to India, and they were talking about these monsoons, and it was interesting because they don't have a lot of the investment for really big infrastructure. But what they did was they changed the way they designed their houses on stilts, and so on these stilts, as the rains came, like it was able to shift. Right, the house was actually able to shift and maintain, stay upright, and that was really, really unique. I think while there's a lot of suffering going on, I think in the recovery, I think identifying, well, what do we have? What do we, what can we do? And what are the other inspirations, globally? Like, do we adjust do we adjust and rebuild really big infrastructure? Do we look at, smaller ways to kind of, reduce the amount of, I guess, the amount of damage? Or maybe there's a way to actually change how we build some of our houses, right? So they're a little bit more resilient, or some of our, some of the way that the waters flow so that they can actually strengthen some of the channels that actually divert the water. I don't know. I think there's, for them, it's hard, especially because I'm not there nor my friend there. But the first thing that came back to me is there are two scales. One is the large scale, where there's an opportunity to change, where they build, how they build, and then the other part on the small scale, like, what about the smaller ways, right? Like changing your houses.
But it raises the questions that there are decisions that have to be made. And I won't use the same decision, the same kind of discussion can be had anywhere, but many years ago, there was an event that sort of threw into question a city of over 1 million people, 20 feet below sea level in a hurricane zone with levees that aren't tall.
Yeah.
As a civil engineer, what's my answer?
Yeah.
Abandon the city. This is not, the city's sinking, sorry, so
Yeah.
I was losing freeboard on the way.
Yeah.
This is not viable.
Yeah.
We're throwing resources after resources. Now, as a French Canadian, I sit there, no, we can't abandon New Orleans. New Orleans
Yeah.
is something much more than what it is. I worry in the United States that we constantly talk about rebuilding. Every time a hurricane comes through, flooding, major, we're going to rebuild. I think that mentality does have to start shifting. And I think we as engineers have a bigger role to play in trying to direct that policy in some rational ways. And now this is big picture infrastructure, obviously.
I love the fact that you mentioned that, because I do think it's a great opportunity for engineers and designers to help foster that conversation. Because obviously it's communities will and whatever they want to, what they want to do. But informing that, learning how to engage, learning how to actually, communicate, these challenges so that they can weigh the trade-offs, right? I love the fact that you pointed that out, because that's the other part of sustainability. It's not just, can I technically solve this? Can they meet it at cost? And can I do it within a schedule? It's like, is this, given what we're trying to do as a society or as a community, is this what we want? And I think designers and engineers have to do more of that, have to facilitate more of that conversation.
And just to add on that, I'm glad you brought it up as well, because it's a thing that people don't say, although a lot of people probably think.
I'm very happy to say something people don't say.
But to follow up on what can the engineers do, what does that mean? Right? What are those possibilities? If we were to up and move New Orleans, for example, what does that look like? How does that work? And how far are you talking about, right? And what's all the infrastructure required for that? Unless you start actually talking about those types of things, everyone's just gonna say, it's too hard.
Yeah,
And give up.
and fostering the conversation. And I think that's something we don't.
Whether or not it should be
Well,
done.
maybe that's another thing that we can add in, that infrastructure, things that are too big for individual, infrastructure is too hard. Infrastructure are those problems that are too hard.
Yeah.
Still gotta solve them.
For sure.
So that actually segues nicely into this question from the University of Minnesota. How might we model the costs and benefits of investing in renewable infrastructure during industrialization?
So the cost, I just from a cost standpoint, as you're, there's lots of ways that people model them, right? People are talking about, there's a recent report, I think it was from McKinsey, on the electrification of industry. And clearly they go through all the scenarios of energy efficiency, what the trade-offs are, how much benefit you actually get from replacing these. So I think there are a lot of existing models that are out there. I think the richer question is not what happens when you place it technologically. I was like, well, what does that actually do for the industry, right? What does it actually do for designer capability? What does it actually do for everybody beyond, like, the US, for example? And that's a harder thing to model, right? Like the environmental impact, I'd say, was a little bit easier, and then the social impact, of that. Would love to be able to model, all three. Economically, I think we have it. Environmentally, life cycle assessment, and then, but the third one, the social impact, I was like, I couldn't know how to answer that. So it's a tough one.
Okay, so I think we have some time if any of our live participants have any questions. Does anyone have anything you want to bring up? All right, well, Dr. Sanchez has to go, so I think
See you
we'll,
next week.
yeah, we'll close this off, but thank you all for attending, and this will be available on the website.
Brandon, there is a question actually.
Oh, okay.
I think Franco had a question. Yeah,
Yeah.
go ahead.
Yeah, but I was too slow, sorry. It's just about I'm a student from computer execution engineering or computer science, as you may call it in the US. And I have a question about the testing of the things, of the ideas that you were talking about, the builds. And what impact do you see in using computer simulation to do the tests on, for example, tension or pressure of infrastructure, and how reliable this is considering the evolution of the capabilities of the computers nowadays, the evolution of AI to this matter. What are your thoughts on this? Thanks.
Much gray here for me to answer. We're doing that now. We have a large project right now where we're doing a digital twin with the Pennsylvania Turnpike on the new portion that they're building down here. The computer simulation is largely taken over in the materials world for materials discovery, as it were. And I guess in the drug world, it's probably the norm, right? I don't know much about that, but isn't that how they figure out what the best drugs now to test are?
That's how they
right?
start the process, yeah.
But I mean, ultimately, a model that's as good as what goes into it, and I'm much too old to be answering this, but I'm a firm believer that one test is worth 1,000 models. And I need that validation. I'm not going to believe it if I don't see it. And in my world, and keep in mind, what I do is all safety related. I mean, we build buildings, we build bridges, and when they don't work, you know, the old saying is doctors kill people one at a time, structural engineers kill them hundreds at a time. If there's something wrong with that model, and I'm seeing this now in the industry, we've got too much black box stuff going on, and people just, oh, well, okay, that's it. The computer designed it, it's good. And unfortunately, we're not going to find the cost of that for another 50 or 60 years when the structure fails 50 or 60 years before its life expectancy. So I'm still a little bit skeptical, but I'm a cynic. So I think you maybe have the wrong team to talk about that question.
I think it'll be a mix. I mean, I share Kent's cynicism to an extent. And it depends on the field. Some fields are further ahead. And have been validated in more cases probably, but I think there's likely to be an element of experimentation for quite some time to come.
Which is more fun anyway.
Yeah, it's the wrong
For us,
group to be
it-
it's the wrong group to be talking
Yeah,
about.
that's right.
A bunch of experimentalists.
Cool. Any other questions? Quiet group. All right, well, if that's it, then we'll call this panel discussion over. Thank you to Dr. Harries and Dr. Clark and Dr. Sanchez for participating. This is a good conversation. All right, see you all.
Thanks, everyone.
Thank you.
Yes.